Alright, today we're looking at surface area and volume of prisms. We've got the surface area formulas there for rectangular prisms and square-based pyramids. Volume is a little bit more tricky. We'll get into that over the next few lessons really, but let's make a start with these few questions. So to find the volume of something, if you've got the area of one surface and then it's a prism so that it doesn't change in that area on the other side of it, if that makes sense, or through it, all you need to do is multiply that surface area by the height or length of that shape, and it gives you the volume. So in this case, if we've got the area of the top of this shape is 10 centimeters squared, and we're multiplying by 5, that's simply 10 times 5, which is 50 centimeters cubed, because we're talking volume. Same kind of thing here, so we've got the top of this shape, hexagonal prism by the look of it. So we do 4.2 times 7.1, which is 29.82. Meters cubed, because again we're talking volume. So volume of this shape, we can just multiply the height by the width by the length. So that is 2 times 3 times 5, which is 30 centimeters cubed. And the surface area, so this will be 2 times if you want to think of it as this front side and the back side, which is 2 times 3. We're doing 2 because we've got 2 of those sides, plus this face and this face, which is 2 times 5. And the top and the bottom, which is 3 times 5. Again, there's 2 of each of these faces, so that's why we're doing that. And that becomes 2 times 6, which is 12, 2 times 10, which is 20, and 2 times 15, which is 30, and that is 62 centimeters squared. Again, it's squared because we're talking surface area, or you might see total surface area is what you're talking about as well. So we've got the volume and total surface area of that shape. Let's have a look at this next one. So volume here, we might want to go back to our triangular shapes here. Oh wait, where are we? Here we go. So this one here, because we're talking volume, we're going to do half of this front end times h. Is that what we're finding? Yeah. So we're going to find the area of this here and then multiply it by the length. So that is 4 times 3 over 2, all multiplied by 6. 4 times 3 is 12. 12 divided by 2 is 6. So that's the same as 6 times 6, which is 36 centimeters cubed. Surface area is a bit tricky for that one, but you'd find this face and the face at the back, the triangle at the back, the top, if you think of it as like a ramp, the bottom, which is down here, and then the back, which is over there. So just break the shapes up if you're finding total surface area. Alright, question 5. This is a little tricky. We're talking a square-based pyramid. We've got formulas as well, so you can use this one here if you're looking at the slant height and the base squared, so you can use that as a formula. But another way to think of it is if we've got 4 of these triangles making up this shape and then one base, which is the square, we can do 4 times the triangle, which is 2 times 3 over 2, plus the base, the rectangle, square, which is 2 squared. So that becomes 4 times 3 plus 4, which is 12 plus 4, pretty straightforward, 16 meters squared. And we can use this formula up here as well to do that. So if I put it in here, we had 2 squared plus 2 times 2 times the height was 3. I'm hoping this comes out the same. So yep, and that's going to be 16 meters squared. So you can use that formula, but sometimes it's easier to just think about the shape you're working with when you're doing total surface area and go from there. Sometimes you need to find the height up the middle of one of these pyramids. It's something that you'll get quite a lot in senior school and through measurement in different topics. To do that, we're using, again, Pythagoras. So you can see I've drawn out the triangle, and I found that the height is 2 root 2, or we could call it 2.83 if we wanted it as a decimal. So just keep note of that. You might need to use Pythagoras in the next few lessons.